we are going on we're continuing our journey. No, we're not going. We're continuing our journey of summarizing question 2.3, comparing and scaling. All right. Norley's, whatever her name is, car uses 20 gallons of gasoline to go 600 miles. Right, 2 unit rates. All right. So I could do miles per gallon, and that's how we normally report car fuel efficiency. So miles per gallon, miles divided by gallons, and so we went 600 miles on 20 gallons for a grand total of 30 miles per gallon. But our other unit rate would be gallons per mile. Well, let's do it that way. So we have 20 over 600. Now, all of a sudden, you can already see why this is less acceptable, because we're going to get an answer that has it's a very small number. The scientific notation may even make sense on this one. That's really small. And so we get, for each gallon of gas, for every mile, we use 0.03 repeating gallons per mile. Now that doesn't make a whole lot of sense to us intuitively, and which is why we as society have agreed to do miles per gallon or kilometers per gallon if you are not in the United States, because we are the only ones who seem to want to do it that way. All right, so the graph below shows the relationship between distance d and gallons g. Which unit rate appears on the graph? Well, we can do the same thing we did before. Let's go ahead and make our constant of proportionality triangle. No reaction. All right, so from this point here at the origin of 0, 0 to this point of 2, 60, I have a vertical change of 60 and a horizontal change of 2. Where did I get the 60? Well, I'm looking at my scale here. Where did I get the 2? I look at my scale here. Great, that one didn't work so well. So, well, if I went 60 miles in 2 gallons, how far did I go in 1 gallon? Well, I could just do 60 divided by 2, which is 30 miles per gallon, which is what I got before. But this time, I used the graph to find my constant of proportion. A little louder. Constant of? Come on, let's hear it. Proportionality. All right. Write an equation relating distance and gallons, D and G, that's appropriate to this. So we're dealing with our proportional relationships, and our proportional relationships, we're not adding or subtracting anything, and we are figuring out that our distance traveled is going to be equal to 30 miles per gallon times the number of gallons I've used. Which coordinate pair represents how far this girl can drive on 1 gallon of gas? On 0 gallons of gas. Well, which coordinate? Well, so I'm going to use red here. For 1 gallon of gas, if I go to 1, go up right here. For 0 gallons of gas, let's use yellow. 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 All right, we get 0, 0, because if I don't use any gas, I didn't go anywhere in a car, because I'm probably not pushing a car to Grandma's house. Yeah, over the hill and through the woods. That's true. What? You can go through the woods. Roads can go through woods. Okay, I digress. All right, 5. Josh used the proportion. Oh, proportional logic. Love it. 600 over 20 is equal to x over 4. So I think he's trying to figure out how far he'll go in 4 gallons of gas. And that's exactly what it's asking. So the question is, says he can use a unit rate. Yes, obviously can. Do you agree with Josh? Okay, let's read the whole question. Josh used the proportion to find the number of miles Norley's car can travel 4 gallons of gas. She says, use the unit rate because that is going to be a little more efficient. And do you agree with Josh or with Lisa? And explain. And the answer is, I could do both, because I could use this unit rate here. I could say 4 gallons times 30 miles is going to be equal to 120 miles. Well, 30 miles per gallon time. Or I could look here. What did I do to 20 to get 4? Well, I multiplied it by 1/5, because that's the same as dividing by 5. I could do the same thing here, 1/5. And 1/5 of 600 does happen to be 120. And you know what? I'm going to just stick with that. All right, so that is part B.